We are going to look at how to find how fast something is changing using a simple example. Let's say we have this function. Here x is time in minutes and f of x represents the total amount of rain collected in a basket in gallons. So for example, if x equals 1, then f of 1 tells us how much rain has collected after 1 minute. But what if we want to know something different? Like, how fast is the rain collecting at a specific moment? This is where the derivative comes in. When we take the derivative of the function, we get this. Let's say this is the original function. This new function tells us the rate of change, or in this case, how fast rain is being collected per minute. Now let's try an example. What happens at x equals 10 minutes? At 10 minutes, rain is collecting at a rate of zero point 0.7 gallons per minute. The slope means zero point 0.7 gallons per minute is being collected. This is called the instantaneous rate of change. That is the exact speed at a specific moment. This The instantaneous rate of change is not constant. It actually changes depending on time. For example, at x equals 1 minute, the slope is different. This tells us that the rate is increasing over time.